Okay, so today we're going to be looking at section 4.5. We're going to be graphing radical functions. So what I have up here is the two parent functions for the square root and the cube root. We're going to graph these parent functions. We're going to identify the key points and the domain and range. So first things first, as in all things, we make a table for the square root. What we're looking for is we're looking for things I can take the square root of. So if we look at that, we want to find perfect squares. And what are the perfect squares? In case you have forgotten, we have 0, 1, 4, 9, 16, 25, and so forth. And they're perfect squares because this is 0 squared, this is 1 squared, 2 squared, 3 squared, and this is how you can generate as many as you need as you're graphing this out. And the reason why I want to know these is because I want to know what numbers I can plug in here that I can take a square root and not get a decimal response. So that's the key to this. So our table then will be generated by that. For square roots, we need to keep in mind some very simple facts about square roots is that the x value has to be greater than or equal to 0. It cannot be negative. Negative values, as you remember, imply that we're going to have a complex number, and we're not graphing complex numbers. So here is x and y. So this one has a starting value. And the starting value, the start value is, take the radicand. What is the radicand? The radicand is the number under the radical sign equal to 0 and solve. This will give you the start value. So what is the radicand is the number under the radical. So take that, set it equal to 0, and that tells you where to start. So when x is 0. Okay? And then we want to find what can I plug in for x that will give me a 1. In this case, it's going to be 1, and then it's going to be a 4, it's going to be a 9, and then 16. And so these answers, when I take the square roots, are going to be 0, 1, 2, 3, and 4. So that's basically how this is going to work in both scenarios. So we have a dot at 0, 0, 1, 1, 4, 2, and 9, 3. We have a start value, so you want to make sure you always label the start value. Okay, and we draw this curve. It's like the top half of a parabola kind of thing. Just like that. You label one point here and another point somewhere along the line. It doesn't matter where. And that graph would be complete. Because it has a start value, the domain and range also have, we have a domain and range other than all real numbers. So my domain is, well, where does it start? On the x-axis, this graph starts at 0, includes 0, and then continues on in a positive direction. So it is all the real numbers. X is greater than or equal to 0. For the range, same idea, just for the y-axis. It doesn't start until I hit the 0, 0, and then it's all the y values above that. So all the real numbers, the y is greater than or equal to 0. So this is our parent function that all of our square root graphs are going to be related to. Okay, let's look at the cube root, a little bit different. The cube root has perfect cubes. So what are perfect cubes? Now the thing about the cube root and cubes is I can have positive and negative values under the radical because it's a cube root, not a square root. So 0 would be in the middle, then 1, because 1 to the third power is 1, 0 to the third power is 0. The next one over would be 2 to the third power, which is 8. Then 3 to the third power, 27. And then that can continue on, and you can figure the other ones out. But there's also a negative version. What is a negative 1 cubed? A negative 1 to the third power is negative 1. What is a negative 2 cubed? Negative 8. And so you can see that you have the same as the positive version, just in the negative side. So negative 27 is also a value in our problem. And so we make our table the same thing as before. You start off with the radicand. And the radicand is what makes that 0, tells me where the middle is. Okay, so in this case, x is equal 0 is the middle. So this is your standard numbers that you can deal with. Sometimes we just go from -8 to 8. And so, but 0 is in the middle. Okay, and so this one over here is, the next one over would be 1, the next one over would be 8, then it would be 27, -1, -8. And then the cube root of all these answers are -2, -1, 0, 1, 2, 3. And then you graph what you can see. So we have a dot at 0, 0, 1, 1, -1, -1. And then over at 8, we're at 2. And then at -8, we're at -2. And what you're going to get here is very steep. It's going to come around through here. And then it's going to come down here and get turned just like that. Then it's going to come off and go off through that point, all the way off through that point, like so. So it looks something like that. Label the middle. And one other point on each side of that. So you can put in 8, 2. You can put in -1, -1. Any 3 points on there is fine, but always make sure you label the middle one. So there's the parent graph for the cube root. Okay, and so all these other graphs we're going to be doing are going to be based off of these through transformations. So we want to make sure we remember our transformations. So here's the list again. Okay, here's our generic format for any root. Inside is your horizontal transformations. The numbers outside the radical are your vertical transformations. E is your up and down. A is your stretch and shrinks and reflection on the x-axis. Inside, B is your horizontal stretch or shrinks. And then once you have that, then we have our right or left, which is based off of what makes that 0. And so that's what we want to shoot for as we go through our problems on the next page. So we want to be able to list our transformations and then graph our new graphs. So let's go take a look at some examples and see what we can do. Okay, so here's our first one. It is a square root graph. We have some transformations. We want to make sure I can identify the transformations and list the domain and range when we are done. Okay, so we can go through and list our transformations, but before I do that, as I suggested, the first thing you should do is take the radicand, set it equal to 0, and solve this, because that number right there tells you quite a bit. Okay, that number tells me the start of my table, and it also tells me right or left. When I set it equal to 0, whatever I get here tells me right or left. Since it's a negative, I know I'm going to the left 1 unit. So when I make my transformational list, I can say I'm going left 1 unit. This is a vertical stretch by 2, and then down 3. So there's my list of transformations. And then I can make my table, have an X and a Y. And then we need to figure out where we're going to start. We are going to start at -1. Okay? Now, if you go back to the parent table, you can kind of see how this kind of stuff lays out a little bit. This number right here is basically the new 0. That represents that number right there. Because when I take that number and I plug it in, I'm going to get a 0 under that radical. And the square root of 0 is 0, so that's why it's related to this one. And then what I usually do is I keep in mind that the next number over is going to be a 1, and the one after that's going to be 4. So what I do is over here, I think, what number do I need to plug into this to get the number 1? I need to plug in 0. Okay? And then I ask the question, what number do I plug into here to get the number 4? I need to plug in 3. What number do I plug into here to get the number 9? I need to plug in 8. Now, we said we're going to go to the left one or subtract 1 from everything. So if you look at this parent function up here, this table, take that number, subtract 1. I get that. Take that number, subtract 1. Take that number, subtract 1. take that number, subtract 1. You see how this works? I can take that number, subtract 1. So I know this next one here is going to be 15. So that's how I use my parent table to help me make my new table with the transformations, which is the purpose of the transformations, is to make graphing easier and quicker. Once I have this, then I know what I'm going to get every time I plug one of these things in here. When I take -1 and plug in here, that answer is 0, the square root of which is 0, times 2 is 0, minus 3. So in a square root graph, your right or left and your up and down is the first point in your table. Okay? It's the starting point. Next number I plug in here, I plug in 0, I'm going to get a 1. The square root of 1 is 1, times 2, minus 3, -1. If I plug in 3, I'm going to get a 4, square root of which is 2. 2 times 2 is 4, 4 minus 3. Plug in 8, I get 9, the square root of which is 3. 3 times 2 is 6, 6 minus 3. And then if we need it, who knows? Plug in 15, it's going to be 16, square root of which is 4. 4 times 2, 8. 8 minus 3. So then we start graphing. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, -2, -3, -4, 2, 3, 4. So you can see, even on my table I have this value, it's not going to be able to be graphed. So I graph all the rest. Here's -1, -3, 0, -1, 3 goes to 1, 8 goes to 3. This is my starting value, and it's going to go off in a little arc in that fashion. Label this point, -1, -3, and some other point over here, since I'll do this one because it is a y-intercept. And there you go. Okay, transformations, table, drew the graph, labeled it. What is my domain and range? My domain and range are going to start here. It's all the real numbers. The x's are greater than or equal to -1. And my range is all the real numbers. The y's are greater than or equal to -3. Okay, let's look at the next one. So I have this, same thing as before. Take the radicand, set it equal to 0, solve it. Now in this particular case, okay, this is different. For these right here, this is the start value, this is the middle value. Okay, so when I make my table down here, when I make that table, 2, 3, 4, 5, 6, I don't know how many I need, but it's going to be in the middle. That's the number that goes there. And it's the same process as this one over here now. I'll do the transformations here in just a moment, but see, that 2 we just found is this middle. So I'm going to use this parent table to help me figure out, because it's these numbers I can take the cube root of. So I want to get to those numbers in my table. All right, let's list our transformations. From that right there, it also tells me my right or left. Since it is positive, I know I'm going to the right. 2. Okay, be careful here because it is written backwards. This negative is in front of this, so we have a -1 as A. A is -1, which means I have a reflection across the x-axis. And then this one out in front here, this is the up and down. And since it's a +1, it's up 1. Okay? All right, so from our parent table and such, if this is the 0, then I need to find the next number I can do would be 1. Remember, it's 0, 1, 8. If we can just graph those, we'll be fine. So what number do I plug in here to get a +1? Well, I need to plug in 3. What number do I plug in here to get an 8? Well, what minus 2 is 8? Well, 10 minus 2 is 8. Okay. What number do I got to plug in here to get a -1? What number do I plug in here to get a negative 8? Negative 6. And that's a good place to start. I don't really get it. Very rarely you're going to be able to get to the 27. So there's no need. Look at my graph up here. You can see there's no way I'm going to get to that. Hopefully we can get out to 10. But if you can't get to those, then you don't get to those. All right. But 10, you should be able to graph it out too. I didn't make it in this one, I don't believe. Let's do our scale and see how far we can go. So I just missed 10. 10 would be right about here. And 1, 2, 3, -1, -2. Let's see what we end up with here. So if I plug in a 2, I'm going to get 0, and 1 minus 0 is 1. If I plug in 3, I'm going to get the cube root of 1, which is 1. And 1 minus 1, 0. If I plug in 10, I'm going to get an 8. The cube root of 8 is 2. 1 minus 2, -1. If I plug in a 1, I'll get -1. The cube root of -1 is -1. 1 minus a -1, 2. Plug in the -6, this becomes -8 inside. The cube root of -8 is -2. And so 1 minus a -2 is 3. Okay, so let's graph what we have and see what we can do here. So 2, so -6 goes to 3. 1 goes to 2. 2 goes to 1. 3 goes to 0. You're looking for that telltale 3 in a row like that. And then -10 goes to -1, so somewhere right about here. And we'll just use that for a guide. And so we just draw this curve. Come from in here, fairly steep. Go through this one right here. It kind of goes almost vertical, and then it goes off to that way. So make sure you get that little almost up and down mark, and then out to this one, to that point, that direction. Okay, graph your center point, or label it, excuse me, and then 1 point on each side. So here is 3, 0, and this one over here is 1, 2. That graph is complete. There's my transformations, there's my table, my domain, and the range, which I forgot to do on the parent function. So this will take care of it right now anyway, because you can see clearly that this graph has arrows in both directions, meaning it's continuing on forever in the negative direction on the x, in the positive direction on the x, in the positive direction on the y, because it keeps going up, in the negative direction. So literally for both domain and range, and for all cube root functions, the domain and range is all real numbers. There is never a restriction on a cube root. There are restrictions on square roots, but not cube roots. So if we go back to the parent function, which I forgot to do the domain and range for, the domain is all the real numbers, and the range is also all the real numbers. Okay, so you can add that to the parent function side, and there we go. So this is graphing. So when again, and recapping real quickly, find when the radicand is equal to 0. This tells me the start point in my table for a square root in the right or left. If I set the radicand equal to 0 in this one, it tells me for cube roots, it tells me the middle of my table, and then it also tells me right or left. Okay, and that's all the transformations. Make your table based off of the square root and cube root, perfect squares and perfect cubes. Draw a nice smooth curve. Make sure you label everything properly, and domain and range. And so this will be questions that I ask on the test for graphing. And we'll take more problems together in class, and this ends this video.